make sure you have a highlighter with you as you do this. If you didn't get one from me, I have some. So make sure, because you're going to do some highlighting and taking some notes. The cube roots are pretty cool to use, and they're pretty cool to do. So basically what we're thinking of is a little bit different than what we did with the square root. Okay, if you think about it here, we had a square root. Okay, if we had took a square root, remember those dealt with squares, little flat dimensions there that dealt with the area inside and would be able to tell us the outside legs of those things. But what we're going to deal with is a cube root. And a cube root, instead of dealing with 2, it deals with something with 3. So it becomes like a cube, a three-dimensional object. And it's going to tell us the inside, the volume of this cube, because a cube is perfect, like a perfect square. All the sides are the same. So we can be able to figure out the length, the width, and the height of this cube, because if we know the volume, we can take the cube root of it. And what it does is it's able to take it's able to tell us how to be able to take some of this from one number to the next. And here is a little example of what it is. As you can see, a cube root goes in the opposite direction of a cube. So if I take a number such as 3 in this case, and I want to cube it, which is to the third power, and I'm going to follow the cube line here. If I do that, which is 3 to the third power, which turns into 3 times 3 times 3, it's going to give me 27. It's going to tell me that the volume of that cube is 27. But say, for instance, I don't have the sides, and they tell me the volume is 27. How would I find out what the sides are of this cube? Well, I would then take what is called the cube root. And the cube root looks just like that, and it goes the opposite direction, and it tells me that if I take something multiplied it by 3 times to get the number 27, it would be the number 3. So it works the opposite way of what a cube would do. It undoes a cube. Okay, it's kind of like it's gift wrap. You wrap a gift with the cube, and then you unwrap it with the cube root. It goes backwards in this case. A kind of thing of what we want to say is a cube root of a number is basically a special value that when a cube gives the original number. But what does that mean? Basically what that means is when you take a cube root, it tells you the number you cubed. So that's what happens. When I take the cube root of any number, it tells me the number that I cubed or what I multiplied it by 3 times. Okay? So here's a case, an example. The cube root of 27 is 3, because when I cube 3, I get 27. Well, let's write that a little bit more mathematical. So if I take the cube root of 27 and I get 3, that is because if I go the opposite way, 3 to the third power, or 3 cubed, is 27. Okay? So that's basically all it is. They work back and forth just like the square does. So if we can do these just a little bit different than what a square. So let's take a look at some cube numbers and see how the cube root works back and forth. So here's a little table they have back here. And a cube, you can see, will flow this way. So these are the numbers that are going to be cubed or multiplied 3 times. And so this right here will be the answer. Or we can then take and go backwards and take the cube root of these and get the number that number that we were cubing. So in this case, if I take 4 and I cube it, 4 to the third power. Well, remember that's 4 times 4 times 4 times 4, and I'm going to get 64. If I take 5 and I cube it, and I'm moving this way forward, so I'm going to get a bigger number when I cube it. I'm going to get 5 times 5 times 5. So when I cube a number, I'm going to get a big number, 125. When I cube 6, Well, all of a sudden 6 is 6 times 6 times 6, and it jumps to 216. So you can see when I cube a number, the number increases by a whole lot, because you can see 4 is a lot smaller than 64. 5 is a lot smaller than 125. So now, well, what happens if I want to work backwards? So I want to work backwards, and I want to know, okay, well, I have a cube now, and I want to know what is the size of my cube. Okay, so I have my cube here, and it's got a volume of 64. What would be the lengths of that? So if I have this cube and it's 64, what would be the volume of it? So what I would do then is I'd write down my cube root, and I need to figure it out, and I can come up with the volume, the size of V4. I can also do the next one, 125. Take the cube root of that, and I get 5. You take the cube root of 216, and it tells me that it's 3 6's multiplied each other. And remember, these will tell me the lengths of my outside of my cube. While these big numbers, which are my cube roots, they are going to tell me the volume of the inside of the cube. Okay, and so they go back and forth. I can figure out one thing if I know one part of it, and if I know the volume, I can figure out the legs of the other side. Okay, so that's basically how a cube root works. It's just like a square root, but instead you're using 3 numbers instead of 2. That's what makes it just a little bit difficult, a little bit harder in this case. So let's just kind of review a little bit here. And there it is again, the picture of our cube that we have. And basically that's all what we're using. It's a 3-dimensional shape, and we just want to be able to see what happens. So when I take this cube and I cube a number, when I cube a number, what I'm actually doing is I'm multiplying it by itself 3 times. So if I have this cube and I want to know what is 3 cubed, because I got 3 3's here, I got my length, my width, and the height. It's basically saying 3 times 3 times 3, multiplying it 3 times by itself. And when I do that, I end up getting 27. And 27 there would be what is called the volume of this cube. So when I multiply this, I just cube it. I'm multiplying this by 3 times, and that's the inside part. The volume is now 27. So instead of writing 3 times 3 times 3 each time, I can write it down a little bit shorter by writing 3 cubed as 3 to the 3rd power. And that's the same thing as 3 times 3 times 3. Okay, so you will see it written as this way. That's 3 to the 3rd power, or 3 cubed, because of that 3, dealing with a 3-dimensional cube. Well, let's look at some more things with our cubes. What does that mean? Let's look at some here. We've got some examples. So we're just going to kind of write them down. As you can see, the first one, 4 cubed. Well, that equals 4 to the 3rd power. Well, let's expand it. 4 times 4 times 4. And when I do 4 times 4 times 4, I get 64. So that would be the volume of a cube that was 4 by 4 by 4. So the inside would be 64. If I take 5 cubed, that's 5 to the 3rd power. And when I expand it, it's 5 times 5 times 5. And I can multiply that. 5 times 5 is 25, times 5 more is 125. And that's the same as taking a cube that's a 5 by 5 by 5 and telling me the volume is 125. So in that case. So if I took the next one, it would be 6. It's the same way with any number. 6 to the 3rd power. It's not 6 times 3. It's 3 6's multiplying each other. And then you can figure that out. 6 times 6 is 36. 36 times 6 is 216. And you can see there is my cube. And so it's got a volume of 216 because all 3 sides are 6's, 6 by 6 by 6. So basically that's what it is. So I want you to be able to recognize that, how we move forward from what a cube is. Well, the big thing is, though, as well, is, well, what happens if I want to go backwards? How do I write that out? What type of notation do I use for that? This is what they're going to show you. Because they're saying, well, okay, well, I now have a cube, and it's got a volume of 125. So the volume here is 125. I want to know what are the three sides. So like in a square root, so if I go back and you think about what a square root was, and I said the inside was 25, what were the outsides? Remember, you would take the square root of 25, which would have been 5, because 5 times 5 is 25. In this case, I want to know what are the sides of the length, width, and height. So I take the cube root, and so I take the cube root of that, 125. And I can play around and guess what that would be. I can see, let's see here, if I do 3 times 3 times 3, I'm going to end up with 27. That's not it. 4 times 4 times 4 times 4, I'm going to end up with 64. Well, that's not it. And 5 times 5 times 5 times 5, oh, there it is, 125. So the cube root of this is 5. So each one of those sides there would be 5. So that's the sides of here. So that side, and that side there would give me 5. And the volume is 125. So I took the cube root, because 5 times 5 times 5 is 125. Okay? Now you probably have seen me write that funny symbol down. It's called the cube root symbol. And this is what it looks like right there. There's the cube root symbol. And the only real difference, and here it is again, the only real difference between this is, I'm going to show you, is this is a square root. A square root symbol, you should know, the difference is it doesn't have the little 3. A square root symbol doesn't have the little 3. If I want to take the cube root of a number, I have to make a different symbol, so that's why I put the little 3 there. That little 3, which is right here, and then right there in between the little gap there, tells me I'm looking for a number that I can multiply 3 times and get that number back out. So that's why I'm trying to find what my cube root symbol means. Okay? And that's basically what it means, is what can I multiply by 3 times by itself to get that number that's inside that symbol. All right? Now, one other last thing I want you to know about is cube roots, you can also have negative numbers. In a square root, we can't have negative numbers. Because in a square root, if I took a square root, such as this, if I squared negative 5 squared, that's going to be 5 times negative 5 times negative 5. And a negative give me a positive. So if I took the square root of this, it just tells me 5. It's the same thing. I will not be able to get a negative. But on cube roots, I can get a negative. Let me show you. Let's do this one first. If I take a positive 5 and I cube it, so that's basically going to be 5 times 5 times 5. And when I do that, I get 5 times 5 is 25, times 5 more is 125. It's a positive times a positive times a positive. And it's always going to be a positive number. But if I take a negative number, like a negative 5, and I cube it, I'm going to get a negative 5 times a negative 5 times a negative 5. Well, let's think about it. Think about your rules about negatives. If I have a negative times a negative, that turns into a positive. So that turns into a positive, this right here, that turns into a positive 25. And I'm going to multiply it now by my last negative 5. Well, what's a positive times a negative? Well, that's a negative. And that's why I get a negative 125 there. And I can then be able to turn that around by saying the cube root of a negative 125 will be a negative 5. So I can get a negative answer. Whereas a square root here, I see I did a negative 5 squared. It gives me negative times negative is a positive. If I then turn that around, well, I'm just going to end up with a positive again. But here you can get a negative. So if I took a cube root of, say, a negative 27, well, I know, what can I multiply 3 times? Well, I know that's going to be negative 3 times negative 3 times negative 3. So my answer is -3. So my answer there is -3. Because -3 times -3 times -3 gives me -27. So I can get negative answers in this case. You look at this one here, they have -6 to the third power. So -6 to the third power is -6 times -6 times -6. If I multiply those, I'm going to get positive 36 times the -6. A positive and a negative give me a negative. I get -216. If I want to go backwards then, I can say the cube root of -216 is going to be -6. So I can get positives and I can get negatives for these, and you can see those. I'm going to highlight those a little bit so that you can revert back to them if you get a negative answer. Okay. Now the big thing that you need to remember as doing these answers, because this is the last page before you get to your work, is this right here is a list of the first 15 perfect cubes. Use this to help you, and use these as well to help you with the negatives. Because remember, the top part here is my cubes. Those are the small numbers. And then these are the big numbers, my cube roots right here. So when I cube a number, I get bigger. So when I cube, you get bigger. And when I take a cube root, you get smaller. Okay? When I cube a whole number, I get bigger. When I take a cube root of a number, I get smaller. Okay? Now, we'll be able to see those here in this case. You can see when I cube 2, I get 8. It gets bigger. If I cube 3, it gets 27. It gets bigger. If I cube 5, I get 125. It gets bigger. But it changes a little bit. What happens if I have a fraction? If I cube a fraction, it gets smaller. Okay? It gets smaller. The answer gets smaller. So make sure you are aware of that, because you will see that in a minute. You'll see that when you cube a fraction, the answer actually gets smaller in this case. So use these notes right here to help you when you do your worksheet answers, which are coming up here in a second. Okay? So what happens if you've got this, you can always pause it and come back and rewrite this again. I'm going to come back over here. I'm going to do a few with you and let you get started. Okay? So what I would expect for you to do here is to also expand these out. I'm going to do number 7 and I'm going to do number 5. So I'm going to start with number 5. It says this -4 to the third power. So what I want you to do is expand it out. And then you should be able to multiply that. -4 times a -4 is positive 16. And 16 times -4 is, well, that's going to be a -64. And I can always check it by coming back here to my other page here and looking here. Well, positive 4 cubed gives me 64. So if it's negative, because it's 3 of them, will be -64, and I can check it. Okay? If I get a fraction here, we'll see what happens when I get a fraction. We said the answer was going to get smaller. Let's see what happens. So I take 1/2 times 1/2 times 1/2. Well, what I do is I just multiply across. 1 times 1 times 1 is 1. 2 times 2 times 2 is 2 times 2 is 4. 4 times 2 is 8. So I get 1/8. So think about it. Which one is smaller, 1/2 or 1/8? So obviously the 1/8 is smaller. So just be that in mind of what happens when a fraction gets cubed. It gets a little bit smaller. Okay? Then you have these questions here to answer. What happens to your answer as the numbers were being cubed increase? So what happens to our answer when we cube a number and they get bigger? What happens to, and you can use this here, what happens to our answer, and here's the answers, what happens when we start getting these numbers to become bigger? What happens to our answer? The next one asks you what happens to your answer when the numbers being cubed decrease. What happens when we decrease the numbers? What happens when we get smaller? Do the cube numbers get smaller too? And then the last one here, what happens to your answers when you are cubing the fractions? Okay, kind of just answered that one for you. So then you have those. Then we have over here, I'm going to do 2 of these here with you. So if I do these here, you can see here cube root of 0. I'm going to do number 12. Well, the cube root of 0 is 0, because 0 times 0 times 0 is 0. The next one here is, if I do this one, the cube root of 1331. Well, what is the cube root of 1331? Well, I can look back on my little chart and I notice, bam, there it is. It's 11. Oh, so there it is. So I look back here on my little chart. I found it out. Bam, there it is. So 11 times 11 times 11 gives me 1,331. Using these answers up here, you need to answer these questions. When I took the cube root of small numbers, what happens? When I take the cube root of the big numbers, what happens to my answer? And when I take the cube root of negative numbers, what happens there? Do I end up with a negative answer or do I get a positive answer? Okay, so use your notes, use your brain there. You can do it. Try the best you can. If you've got a question, please raise your hand and ask. Thank you.